Okay, hi. I just want to make this because with the system function diagrams, I kind of just had a moment yesterday where I was like, oh, that's how it all works. Um, it kind of finally clicked when I was making my final project diagram for my choice. Anyways, my biggest issue I was having trouble with were the pluses and minuses, where to put them, when to put them, how often to use them. And I'm just going to tell you, well, you did a good job here, Anna, because it's all the time. And I didn't even know. I could not figure that out. And it's also really confusing when to use the minuses. But the thing that you're doing here, Anna, is all these, like these words, just what are the pluses? The pluses are all these words and the minuses. So, and I edited this one already, trying to record it earlier, but water regulation would have to be placed in order to ensure water equality for habitat restoration, industrial usage, agriculture, and residential areas. So that's literally going to be water regulation plus water equality plus, because regulations would add to water equality. And so that's a system, that's a system, that's a system, that's a system, that's a system. So this would be like 6 squares. All this one square would be 6 squares, and all those like adverbs, adjectives, whatever you're using, would be pluses and minuses. But also, this aspect, you pretty much did the whole project, because this is socioeconomic. This would be in the yellow part. This would be over here, because that is socioeconomics. That is not ecological. Ecological is all natural. And then what's cool and interesting is here. This one here, to start reclaiming water from the LA River for habitat restoration. That entire thing, that one bubble, is pretty much the entire ecological system, right? To start reclaiming water from the LA River for habitat restoration. Watch, I'll bring you in the entire loop. And I just want to point out that that is your answer. Frank wants to create a feedback loop where you reclaim water from the river and you put it back into the aquifer. And then also, Alex, you mentioned habitat creation. To allow habitat creation, you need to utilize soft bottom sections. Okay, wetland recovery. We chose to restore the river. We're getting rid of the cement and the infrastructure. So what does that do? Now water is now pooling naturally. It's getting rid of the water and pumping it and pumping it out more slowly, so there's flooding, and that is creating a wetland. And this starts the slow process of recovering. So when the wetland recovers, it starts to naturally moisten the soil, and now you're adding to the soil infiltration, which is again a natural. One second. Which again is a system. So you can say the wetland recovery, the pooling is going to dampen the soil and produce increased soil infiltration, but you take away all those words and you just add the plus, because wetland recovery adds to soil infiltration. Soil infiltration adds to groundwater recharge. And by the way, groundwater recharge, I guess I should say like groundwater storage, is the aquifer. And that is pretty much my final project. I don't know why it's blurry. There it is. That's my final project, is groundwater storage. So think of this as the aquifer. And then this pretty much is actually the ecological system that I have here for the LA River restoration. So groundwater, aquifers pumped up. What does that do? That provides a stable base flow. What is a base flow? Base flow adds to, and up here you'll see, base flow pumps out the water for river flows, springs, and wetland hydration. But it's more complicated than just going straight to wetland hydration. I'll show you. That's what the whole system's thinking is. We're thinking about the system. So, and base flow, it's important to have the water table and to maintain this. My project is about humans fucking it up. See, but we don't need to talk about that right now. So that we're overutilizing it, and it's taking away from all this. Anyways, so to maintain the aquifer, that's important because it maintains the base flow, which, think of aquatic habitat health as all three: the river, the streams, and the wetlands. That is the aquatic habitat health. All aquatic habitats, all three of those. So base flow What does it do for the aquatic habitat health? It adds to it. Plus sign. Aquatic habitat health leads to biodiversity. Animals and plants can start surviving and calling it home. Yay. So plus biodiversity, what pertaining to the shark, what would you do video we did. When you have a diverse population and diverse traits, it leads to ecological resilience. You know, the Black Death can't just come and wipe everything out or wipe out a main contributor. And because you have ecological resilience, that will now add to the wetland recovery. Because yes, the wetland recovery is a slow trickle-down process where it just starts flooding and making the soil wet. But the wetland recovery is also, when you come full circle, the entire ecosystem. So you need to have ecological resilience to promote that wetland recovery and strength. Okay, so see how that, to start reclaiming water from the LA River for habitat restoration, you start reclaiming the water and it leads all the way to the habitat restoration. And then also you have nutrient dense and more biodiversity. There were more words here. I forget. I tried recording it once and I got rid of them because I was making an example, but I forgot to put them back. So, but this nutrient dense would basically be pretty much like soil infiltration leads to natural filtration, leads to better water quality. I would like to say nutrient dense is here because we're creating a healthier soil, and more biodiversity. Again, it's not one to the other. There's a system that we're thinking about. So water quality goes to aquatic habitat health. That's also boosting the wetlands, streams, and whatever. And when you have a healthy water and a healthy habitat, you now get increased biodiversity, which goes to ecological resilience and wetlands recovery. Okay. So what confused me was the negatives. We can come over here. This is another one. So now we chose not to restore the river, so we're going to maintain the concrete. And I didn't know if we get rid of the word limited and just have green space access, because that's the system, but I like to keep the limited because I'm still a little confused on it, and it helps me answer this one. So if you maintain concrete, what does that do for a limited green space access? See, I'm dumb, so I'm thinking, oh, negative, boo. I was just thinking negative signs because bad. But maintaining the concrete, limited green space access, well, you're adding to the fact that there's a limited green space. And then limited green space access, what does that do to public health? It takes away from it. And that's why I leave limited, because if it just said green space access and public health, I don't really know what it does. So I like to have the, like, what is, you know what I mean? So limited green space access, public health takes away from it. And then public health and environmental inequality, what? The limited green space access is low-income communities that were affected the most by the LA River. So these are low-income communities, and they're having negatively affected public health. So the environmental inequality, when you have that, what does it do? It adds to the environmental inequality, so that's a plus sign. So that's what was really messing me up. And then Anna, like I said, you did the whole project here, because some of these things, like this is pretty much it right here, but you have to break it down into the entire loop. But this is technical systems. This is here. This is the blue, I think, right? Because we're talking about like infrastructure. It could even honestly be eco. It could also the socioeconomics, because it's also leading to. No, I think it's technical. This over here, water regulations for habitat restoration, industrial, agricultural, and residential areas. Government would have to create policies and permits for people who need to draw water from it. Policy. That's socioeconomics. So that whole thing would be here. 1 second. So yeah, that whole thing would be here. And again, that's maybe stuff we can add. Do I have that? I didn't add that part, but we'll see. I don't know if we can have to add everything, but that's why you can also, some of them can also be in the descriptions we wrote in the paragraphs. Anyways, yeah. Also, this one right here, water regulations would have to be placed in order to ensure water equality for habitat restoration, industrial use, agriculture. That would be like 6 of these boxes. Water regulations is a system. Water equality is a system. habitat restoration is a system, industrial usage, agriculture, these are all systems. So these would all be boxes, and you would just, all the words in between would just be pluses and minuses. Yeah, also one thing I found with the ecological system, I didn't have any diamonds because these are decision making by humans, and the ecological system really is just a natural occurrence. So there are no decisions to make because this is Mother Nature, right? And yeah, you could say, well, we're deciding to maybe increase the width or whatever, blah blah blah, but that's going to be technical systems. So I couldn't think of any diamonds, and I think that's fine because here where humans are involved and there's policy and stuff, that's when we have to make decisions. But this one I couldn't think of any. Oh, and then I also tried to add a parallel. I'm not too sure, but winter storm precipitation brings in a ton of water. That the surge, that's just a big rainstorm in the winter, like they said. That brings in a lot of water from the outside, so the parallels had to be inputs and outputs. So you're inputting a bunch of new water into the system. And what does this do for flooding? Oh, it adds to flooding. It boosts it. So plus sign. And then what does flooding do to the aquatic habitat health? Well, it's going to, it's heavies, it's washing away established roots. Oh God, what do you call it? Sediment washing away sediments. Could destroy, trees and root systems, all that. And also pollutants. It's washing all the nasty LA stuff into this, and we're getting fentanyl fish. So flood event, aquatic habitat health takes away from it, negative. I hope that helps. I'm just trying to sum it up quick. And like I said, so I don't even know if I touched on that, but wetland recovery and soil infiltration, what are you doing? You're softening the soil and getting it back to the natural way it's supposed to be. So Alex, that is your soft bottom sections, utilizing soft bottom sections to buffer against stream weather and cause climate change and adapt to environmental changes. And it's actually better said in your paragraph here. Passive slow water flow and habitats for native species. Restoration. You said it there somewhere. I'm sorry, I'm trying to rush. I have work soon. And then Frank mentions creating a feedback loop for reclaiming water from the river and putting it back into the aquifer. That's literally this, but you have to have so many steps. Frank, so you're capturing water from the river. That is the wetland recovery, soil infiltration, and we're putting it back into the aquifer, which is the groundwater recharge. It is this. This is the aquifer. Sorry if I'm repeating myself. I tried to record it already, and I don't even know. They're all merged together. So yeah, this is the aquifer. So now we've actually already done that, but there's a whole route, base flow, boost the base flow, aquatic habitat health, and it makes the wetland bigger and stronger, and it will only add to the groundwater. So we'll only add to the aquifer. So that is a feedback loop for reclaiming water from the river. We are reclaiming the water from the river. That's this entire thing. Okay, that's it. Bye.